So for today, it's about logs. Here's why you need logs. Go with me on this. It's going to be easy, but it'll give you the idea. What would you do to solve this one? You divided both sides, right, by 5. What would you do to clear the fractions out of this one? Remember, there's something better than multiplying by 4/3. To clear the fractions out, what would you start with? This is surprisingly hard for people, but it's so easy. You just multiply by the denominator. You times by 4, and then it won't have fractions anymore. Cancels. No more fractions. See how quick that is? All right. Next, there's a right way to start all of these. It's just that one of them, when you get to it, you're not going to know how to do it, and that's because you need logs. All right, on this one, 2 to the x is equal to 8 to the x plus 4. What would you do to start with, your first step? I hope you're thinking about changing that 8 into what? 2 to the 3rd. Okay, good. So that's the first step on a bunch of like equation solving problems. That makes the bases the same. Then you'd set this equal to that. You'd have to be careful that you distribute the 3 right. And you'd say x equals 3x plus 12. And then you'd subtract the variable on both sides. And okay, so there's a right way to start solving. How do you solve that one? What you're going to learn how to do is you're going to do something to both sides. You're going to put a log on both sides, but you don't even know what a log is. And so it's going to be really hard for you to take the log on both sides until a while from now. So really, I got to teach you what a log means first. By the end of this unit, I'm going to keep coming back to today and say this was the most important thing, is can you make exponentials into logs and vice versa? I'm going to change this into something different. That's why I got my big double arrow thing there. I'd like you to use that because this is not an equals thing. It's not like we're writing an equation. We're converting something to from one form to another form. All right. We're converting this to log base 5 of 8 equals x. Well, why is that better, Mr. Server? Well, for one thing, you can put that in a calculator. Would you grab your graphing calculators? I'm going to pause for a second while we do that. Okay. So, if you have your calculators, which I think everybody does now, you got to learn how to put that in. And I found out last hour that only a few kids had this super cool way of doing it. It's not even faster, it's slower. So I'm going to show you the old-fashioned way that works on all the calculators and is the fastest. Ready? And if you have the new software and you want, you can always come up and ask me how to use it. But if you just type in log 8, and it'll automatically have like a front parentheses, you have to hit end parentheses, and you go log 8 divided by log 5. Now, right now, I know you don't know exactly what you're doing. I'm just telling you how to type it in. And I'll later explain how this is called a base change. But for right now, you just type it in the second number first. Again, I know the 5 comes first. But think of it as the 8 is higher. When you read from if you don't read from left to right, if you read from up to down, the 8 would go first. That's the way to think of it. Log 8 divided by log 5, hit enter, and do you have a decimal, sir? What is it? So you're saying then that 5 to the 1.29, did you say? Okay. Would everybody please go 5 power of, and I'd use second answer, because that brings the whole number back, instead of rounding it. 5 to the power of that whole thing, 1.29, blah, 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 blah. And hit enter, and I bet you'll see that it comes out to 8. Okay. So, let's get a different one. 3 to some power is 9. As soon as you realize, you'll be like, oh, x has got to be 2. Okay, that's true. But this also could be solved with a log. So I can just show you that it works. You know what the answer should be, right? So we'll just test our technique and see if we can tell that it works, because the answer should be 2. All right, would you agree this is a log? Base, did anybody catch it on the last one? Which of these three things, the 3, the x, or the 9, do you remember I used for the base last time? The 3. And if you never caught that, now let me explain how this works. Of these, this one's a base because it's got the exponent on it. Granted, 9 has an exponent, but we aren't even showing it. So, all right, so the 3 is the base. Then you jump over to the other side of 9 equals, then you jump back. This did not go in order. Notice, if it had gone in order, I would have said log base 3 of x equals 9. If it was nice and in order, it would have been that, and that would be wrong. That's not it. It doesn't go in order. Do you see how that went? Now, type in log 9 divided by log 3, and you'll get the answer, which we know should be 2, right? 3 to the second is 9, right? Did it work? Okay. She's verified by typing in log 9 divided by log 3. You got 2. 2 is x. Okay, so there's just the really basics of a log. Next, you got to learn what these 3 things are called. This is called the base. I've mentioned it a couple times. This is called the argument. And this last thing is called the exponent. I'd like you to think about why it's the exponent. Well, because look at the original one. Wasn't the x the exponent there? When it's in exponential form, this is exponential form. We just had a test on exponentials. When it's in exponential form, the x is the exponent. When it's in log form, then the answer is the exponent. All right, one more. Log base A of B is equal to C. Ooh, that just got more abstract. What's the base? What's the base? Okay. What's the argument? B. What's the exponent? C. Good. Now let me tell you what A can be. This has to be a positive number. It can't be 0. It can't be negative. It has to be a positive number. Now, did I say anything about whether it could be a decimal or like a whole number? Nope, I didn't say that. It can be a decimal. It can be a fraction. It can be a whole number. But it has to be positive. That I'm going to write this positive number cannot equal 1. There's no such thing as a base of 1. You never do log base 1. I'll show you why later, tomorrow, when you understand more about what a log is. It'll make sense that it can't have a base of 1 once you understand what they are. I'm just trying to tell you the rules. That has to be positive number. This, same basic rules, except it can be 1. So this is simpler. It's just a positive number. It can be any positive number. Is 0 a positive number? No. 0 is not positive. 0 is neutral. So it can't be 0. It has to be a positive number. Could be a decimal? Yep. And C, no rules. With a Z. Now that's not the official, but it can be positive or negative. So I'm just going to say it can be any real number. So basically, your C can be anything. It can be positive, it can be negative, it can be decimals, it can be whole numbers, it can be anything. Because why? Because it's an exponent. And have you learned that exponents could be negative? Yeah, and exponents can be fractions. Yeah, exponents can be whole numbers, like 2, but because that's the exponent spot, there's no real rules on it. It can be anything. All right, watch out for especially negatives. They like to pop a negative in here just to see if you're paying attention. What if they put a negative in one of those spots? Then the answer is simple, no solution. You can just be done right there, no solution. Okay. All right. Next, I showed you how to get this into a log, but some of you guys may still need some practice. Change that into a log. Then we're going to practice going backwards, starting with a log and going the other way. If there's only one thing that I'd like you to be good at the end of the day, it's converting from exponential form, which has the x in the exponent, into log form, which is writing a little problem that says log and has a base and has an argument. Did you say log base 10 of 18 equals x? Okay. Now it's good to get that there is one that's better than the other. One of these forms is easier to solve. By solving, I mean we can get the answer easily. Can you do that easily? No. Can you, assuming you can use a calculator, can you do that easily? Yeah. So that's the better one, the bottom one, because it's solved for x. X is alone. So that's better. You can type that in. The top one, there's no way to type that in. You got to change it from this form to this form first, and then you can type it in and get the answer. Okay? So sometimes we convert it to make it solved. All right. So I'm going to give you a chance to try going backwards. It's like if you learned how to skate as a little kid, I guarantee you didn't learn how to skate forwards. At some point, you got good enough at going forwards that you could go backwards. Different skill. Log base 3 of x equals, let's make this an 8. Log base 3 of x equals 8. Now, next thing I want to concentrate on is how do you say these things? You ask the typical kid to say that, they'll say log 3x is 8. Okay, and that's not it. Mostly because they're missing a few key words. If you're going to say this, you always have to say base. Log base 3. And then usually, to say it properly, we don't just say log base 3x, because that sounds like that the base is 3x. Log base 3 of x. And then you can say equals or other words for equals, like is equivalent to, or is the same as, or just equals 8. Okay, that's how you say them. Next, I hope you were able to rewrite this the other way. Something to the something. I know some people wrote this, and I totally understand what they were thinking, but that's not right. And they might have been thinking, oh, x is always the exponent, isn't it? Nope. Remember, the exponent was the last thing. That's the exponent. So, do you get that the 8 should actually have been here? Raise your hand if you had that right. Awesome. Okay, if you did that backwards, pay attention now. Notice I'm going to go across and then back. You always have to go back and forth in this. You go from one side of the equation to the other side and then back again. All right, let's try another one. Log base 2 of 5 equals x. That's actually already solved for x, but that's not the question. The question is, what would it be as an exponential? Rewrite as an exponential. All right, Dice of Destiny. It's row 1, last person. AG? You are correct, sir. 2 is the what? The base. Do you get how it's kind of the lowest number here, which kind of makes it like a base? And do you get that this one, it's a base because it's got a power on it? Does that make sense to you? So base kind of works. What's the weirdest word? Argument. That's the argument. We could argue about why it's called the argument, but the last one is exponent, and that's, of course, the same as that. That's the exponent. So do we call this the argument? Not really. It kind of is, but you don't have an argument unless you have a log. All right. We're really getting close to you having known enough to be able to do these on your own. So let me give you a few practice ones, and then we'll see if you're ready to start your worksheet. By rewriting this as an exponential, you'll be able to see if it's true. Just because I wrote it on the board doesn't mean it's true. Is log base 3 of 9 actually 2? Well, I know you could type it in your calculator, but not using the calculator, couldn't you just rewrite it? All right. Row 1, middle person. Because 3 to the 2 equals 9. Good. All right. Next one. 5 to the x equals 27. Tell what x is between. What? Would you agree that 2 would be too small? 5 to the 2 would be too small. Would you agree that 3 is too big for the x? 5 to 3 is 125. So what's it closer to, 2 or 3? So what do you think the answer is about? 2 point what? What do you think? 2.2-ish? Well, how can we know for sure? First, change it to a log and then put it in the calculator and see if it is about 2.2. Somebody said it's like 2.2. Let's see if they're right. I'm guessing 2.1. I haven't typed it in, but I know it's really close to 2. Did you write log base 5 of 27 equals x, and then you type that in, and then, do you have a calculator? Okay, using a calculator on the iPad? Okay, you actually use it then, because I didn't see your hand moving, makes me wonder if you're doing it. How about you? Were you? Okay, good. What'd you get? 2.04. Wow, that even rounds closer to 2.0. Is the answer actually exactly 2? No, but you could round it to 2. What'd you get? 2.05? Okay, fine. Close. So, I think you've learned almost everything that you need. So, let's go look at the worksheet together. I'll pause for a second. Pull that up. All right, so here's our worksheet. It is called Intro to Logarithms. All right, so I'm hoping you're going to find that it's pretty easy. I do like to try to keep them reasonably sized, so we are going to cut off that last line, I, J, K, and L. If you want to do them for extra practice, you can. I might use them as a warm-up tomorrow or something. All right, here we go. What's the base on this one? 2.1. What's the argument? 25. Awesome, that was easy. How about this one? What's the base? 9. What's the argument? Trick question. You should always simplify. So instead of root 8, you should go root 4 and root 2, which would make 2 root 2. It was a trick question. I know that's vicious. It is the square root of 8, but you should simplify it. Okay, next one. What's the base? You'd think it would be b, but no, they did that on purpose. What's the base? What's the argument? B. Okay. Then rewrite these in exponential form. It's in log form. You've got to be able to go both ways. I always recommend starting with the base because the base really makes sense. Most people would say that's at the base of the log. Base means like bottom. It's the lowest number. And then you always jump around. Don't just go in order. The most common mistake is 3 to the 9th. That's wrong. And now, it does not ask you to simplify and solve this. I could do it, n is obviously 2, but I don't need to. You do have to do that when you hit number 4, because then it says simplify. On those, you actually want to get the answer. All right, let's keep going one thing at a time here. This will be 8 is the base to the power of not 64 to the 2 equals 64. And it's a true statement. 8 squared is 64. Yay. Okay. On to number 3. Rewrite this in logarithmic form. Log base, what? 5 of, jump around, 25 equals n. Okay, let's just do one of that last kind where we are rewriting it in an exponential form and simplifying it. Well, then there's no variable. So then you say equals x. That's important, right? I mean, on all of these, you could say equals x. Then, when you rewrite it, you have an exponent to put there. 3 to the x equals 81. And then you can go, ooh, I know that one. 3 to the 4th. Yes, x is 4. You're supposed to simplify these down to the answer if you can, which we can. Because 3 to the 4th is 81. 3 times 3 times 3 times 3. Okay, this next one. Equals x. 4 to the x equals 4. Gee, I wonder what x is. See what I mean? You can get these answers and actually finish them. Figure out what x is. All right. I'm sure you will finish this puppy with time to spare. And that's your intro to logs. Now I'm going to hand those tests back.